between NASA and the German Research Center for Geosciences. And you know what? The weather seems to be cooperating for today's launch. The 30th Space Wing Weather Squadron here at Vandenberg tells us things are looking good. There is only a small chance of violation, less than 10%, which means we're 90% a go for launch. Ground winds out of the southwest are the only concern, but overall, it's simply a gorgeous day to launch a rocket. Hello everyone, I'm Ye Hill with NASA Communications. I'll be your commentator for today's launch broadcast. With me is Sami Kayali. He's Director for the Office of Safety and Mission Success at JPL, but previously he served as the Deputy Project Manager for Grace Follow-On. So he's here to help provide insight and also to help us along understanding what's going on with the launch. So the first question I have is, this is called a ride share. Can you explain?
Sure. The Grace Follow-On team was able to establish a collaborative cost-sharing agreement with Iridium, where we took capacity that they had on a launch vehicle, and NASA GFZ would be able to launch the Grace Follow-On twin satellites, while Iridium would be able to launch 5 of their communication satellites to satisfy the constellation.
So we're literally sharing the ride to low Earth orbit.
Exactly.
Yeah.
Yes.
So this is also a partnership between Germany and the U.S. Can you talk about who did what?
Sure. The NASA GFZ agreement actually made it very clear early on about the roles and responsibilities on this mission, which made it much simpler for the team to actually focus on their work and get things done. As part of that agreement, JPL was responsible for the development and build and test of the 2 spacecraft, and also the build of the microwave instrument and the laser ranging interferometer. The Grace GFZ was responsible for the launch vehicle service, and also the mission operations, and also the optical components that go into the laser ranging interferometer.
And we have some video to show of the road to launch for this spacecraft.
Yes, you'll see in the video that this is a video that shows the construct or the fabrication of the 2 spacecraft at the Iridium facility in Germany, in Friedrichshafen, Germany. These are very delicate spacecraft, of course, that rely on very precise measurements of the gravity field. After they're tested, they were shipped over to Vandenberg Air Force Base for completion of the overall integration and into the multi-satellite dispenser that I'll show you in a minute. This is the Air Force personnel actually helping us offload the spacecraft. This is at the Harris processing facility here at Vandenberg, where we process the spacecraft. You see them unloaded here on the multi-satellite dispenser, which allows them to be deployed at the same time from the launch vehicle.
All right, so throughout these events, we'll be hearing from the team, the SpaceX launch team, but the team itself will have certain communications that you'll be hearing on a special network with the team members. You're monitoring it, Sami is monitoring it for communications, so we will be checking back with you throughout to get updates on the mission.
Sure.
All right, thanks, Sami. Well, let's tell you a bit more about the mission now. It's called Grace Follow-On because it's following in the footsteps of an innovative mission that lasted 15 years. It was called the Gravity Recovery and Climate Experiment, or GRACE. And GRACE revolutionized our understanding of how water moves around our planet. And Grace Follow-On aims to keep the information coming and continue the legacy.
Water is one of the main indicators of how the planet is responding to our evolving climate. We built our civilization around the climate that we had and the water resources that we have. And if those are changing, that can have a profound impact on how we operate our society.
Grace and Grace Follow-On measure the motion of water around the Earth, and they measure that in all forms of water. Water that's stored underground, water in the ocean, water that's frozen in the form of glaciers. So all of that together, Grace can measure.
GRACE Follow-On is a mission to measure how water is distributed on the planet and how that changes from month to month.
GRACE stands for Gravity Recovery and Climate Experiment.
And it's a follow-on mission to this mission called GRACE that we launched in 2002. And that mission just ended a few months ago, and GRACE Follow-On is going to pick up and continue that science legacy.
Even though GRACE flew for 15 years, climate is one of those things which takes place on decadal timescales. It's really important that we look at these trends over longer time periods so we can establish the forces which are driving them.
One follows the other, and between them they accurately track the distance between the two satellites. And as they fly over changes in mass on the Earth, they move back and forth. And we track those little changes very accurately. And we do that with Global Positioning System satellite information and with star cameras that are on board the two spacecraft. I think there's an increasing awareness and consciousness around the Earth that water is a critical resource and that the sea level is rising, the polar caps are melting, and that all these have long-term ramifications on how we live.
The GRACE follow-on measurements give us very clear and tangible information so we can make sound decisions in the future of how we manage our resources.
Now, there wouldn't even be a GRACE follow-on had the original mission not been such a game changer. With me now is Frank Webb. He's the project scientist for GRACE follow-on. What exactly did we learn from GRACE?
So GRACE was very revolutionary in that it provided us with the first global comprehensive view of how our water system works, how our water cycle works in the globe. You know, so the water cycle is a very important component of our.
So we have video of some of the things and we can roll that video right now. Okay. What did you see here?
So in this map, we're just seeing sort of global water trends. And the water cycle is composed of many components, and that's water in different reservoirs on Earth. It's water locked up as ice, water in the ground is groundwater, water in the oceans, in rivers, in the soil, in floodplains. And so with GRACE, we were able to, over 15 years, look at the trends in those water reservoirs and see whether they're gaining or losing water mass, essentially. And you know, in this chart here, you can also see, you know, some of the big changes, such as in Greenland and Antarctica.
Let's talk about that. The big changes, the big surprises, or was that a surprise?
Well, so when GRACE was launched, we knew that, you know, mass moves and ice sheets in the oceans, you know, gain water or lose water. But we didn't know exactly how much was being lost. Even in Greenland, we didn't even know what the sign of the change was. So with GRACE, we were able to actually measure the amount of water that was being lost and what the rate was and where in Greenland it was being lost.
So here we have the video of that, of what you saw.
So in this video, you can see on the left, there's a map of Greenland, and the browner colors show places where more mass has been lost from Greenland over the lifetime of GRACE. And you see there's a lot of ice being lost from southern Greenland. It gets browner and browner as the time series goes on. On the right, you see the plot of sort of the monthly changes. You can see sort of seasonal changes, but see overall there's a overall loss of mass in Greenland. And it's losing mass at about 281 gigatons of water each year.
And let's talk about that. A gigaton. I mean, give me, a layperson, an idea of how much water are we talking about?
Yeah, a gigaton is kind of a strange unit, but it's a mass unit. It's the amount of water that would fill a kilometer cube of a kilometer cube. So in this animation here, you just see a cube of water, a kilometer on each side. And we see here at the end, you know, there's the Empire State Building for reference. So that's 1 gigaton. And now GRACE follow-on showed, or GRACE, excuse me, GRACE showed that Greenland was losing 281 gigatons of water a year.
So 281 of those per year. All right, Frank, I'm sure you're excited about this moment. We're standing by. Thanks so much for joining us.
Thank you.
All right. Well, it is about 25 minutes past the hour. We are keeping our eye on the clock for 12:47 Pacific time. That is lunchtime. But meantime, let's talk about some quick facts about GRACE follow-on. 27 minutes past the hour. Very soon now, we hope to get a status report on the satellites. We're having Sammy listen in for us on the team to find out some important information. Right around this period from T20 to T16 is kind of an important moment for the team, is it not?
It is. This is the time where we hear confirmation from the launch vehicle that the propellant loading is continuing, the liquid oxygen loading is initiated, and then also we hear confirmations and commitments from the launch team, from the Grace follow-on launch team, about the status of their system and readiness for launch.
So every minute or so for the next couple of minutes, you'll be hearing from people in the control room giving these status reports. Are these go for launches?
Correct. So every subsystem will report to the Grace follow-on project manager for the satellite, for the mission operations center and such, and they will report to him the status of availability of the assets that they have, the personnel, and the systems are all go for launch.
At about T20, I understand, is that usually the time where they decide to go to internal power? When they go to internal power, what does that mean?
So the spacecraft are now powered by, they're plugged into a power supply essentially, and at T20 they're given the order or the command to go to internal power, which means the spacecraft now will be disconnected from the external power, will be operating on their own internal battery power.
And then after that, that means
they're ready for launch. They're readiness for launch, correct.
Good to go. All right, so we are standing by. We should be getting that fairly soon.
We should be getting confirmation very soon.
All right, and once we get these goes, the rocket itself and the spacecraft, everything is automated from this point on, is it not?
Correct, pretty much automated. There are, of course, notifications throughout. If there is any problem in the launch vehicle process, they have an ability to halt the launch, but we don't anticipate that at all. Everything has been nominal on every measurement that we've seen.
And have you heard any communications yet?
Not yet. We'll get confirmation in just a second.
All right, so as we watch the rocket, we are standing by. All right, Sammy, we do have something now.
Correct. We just received confirmation that the spacecraft are green for and go for launch, and the Mission Operations Center is green and go for launch. And that confirmation was provided to the launch vehicle.
All right, and we will be getting more?
We'll be getting a final confirmation from the launch vehicle at this point that they are ready for launch.
All right, okay, standing by for more.
Good afternoon from SpaceX headquarters in Hawthorne, California. Welcome to the webcast of the Iridium 6 and Grace follow-on missions. We're flying 5 Iridium Next satellites to join the 50 satellites previously placed in orbit over the last 16 months. In addition, we are flying the Grace follow-on mission made up of 2 satellites. Grace stands for Gravity Recovery and Climate Experiment. And you're seeing a live view of Falcon 9 as we prepare for launch in just under 15 minutes from now. Today's launch is scheduled for 19 hours, 47 minutes, 58 seconds Universal Time, or 12:47:58 p.m. Pacific Daylight Time. I'm John Innsbrucker, the Falcon Principal Integration Engineer, and I'm broadcasting from the mezzanine at lunchtime here at SpaceX headquarters, overlooking our Launch Support Center. And I'll be providing you updates throughout today's launch and flight which will be lasting just over 1 hour. Now, today's mission will be different from most of our flights. We're deploying satellites into 2 different orbits. So once we get into the first orbit, stay with us as the GRACE satellites will be deployed just over 11 minutes after launch, followed by the Iridium Next satellites 55 minutes later. Today's launch is from Space Launch Complex 4 at Vandenberg Air Force Base, a nice view you can see right there on the webcast. We have the 2-stage Falcon 9 vehicle standing 70 meters tall on the launch pad. Now, to put it in comparison, that's longer than the wingspan of an Airbus 380 or a Boeing 747. The first stage provides the initial force to get us out of the majority of the Earth's atmosphere. The first stage on this flight is easy to spot. It still bears the reentry soot from the re-entry on its previous flight. Now, this is the second flight of this booster, having first flown just over 4 months ago out of Cape Canaveral. Unlike our newer Block 5 boosters, this first stage is not planned for additional flights, so SpaceX will not recover it today. We will be following the second stage as it takes the satellite from the edge of space and accelerates it to orbital speeds of just over 7.5 kilometers per second. Now, as a reference, that takes us faster than 10 times a speeding bullet. Now, we're going to follow the second stage into orbit, and partway through, while we're just after stage separation, you'll see the payload fairing separate. You can see the fairing on top of the Falcon 9 right now. That's a 17-foot diameter object, inside of which are the 5 Iridium Next satellites and the 2 GRACE follow-on satellites. Now, for this mission, we will attempt to recover the payload fairing as part of our ongoing fairing reuse initiative. There's a view, a shot from the Falcon 9 payload fairing retrieval ship called Mr. Stephen, currently on station in the Pacific Ocean. Now, the ultimate goal of recovering the entire vehicle is part of our overall plan for Falcon, as well as the follow-on rocket that takes us to Mars and interplanetary. So fairing recovery is an important step towards that goal. Meanwhile, back on the launch pad, next to the rocket, you can see the transporter rector, the large white frame structure that contains plumbing, air conditioning, and electrical systems that feed both the rocket and the satellites. And one reminder, unlike the East Coast launches, the transporter rector will begin moving away at T-minus 4.5 minutes to its final launch position, 77.5 degrees up from vertical. T-minus 11 minutes and counting. And as we like to say in the webcast, the Falcon 9 team is working no issues. On the Falcon 9, we began loading propellants at T-minus 70 minutes. Currently, fuel, RP1 kerosene as it's known, is completely loaded on the second stage. Fueling is continuing on the first stage. That will finish loading about 7 minutes before launch. Liquid oxygen loading is ongoing on both the first and second stages and will wrap up in just the last minutes of the countdown. Now, our next major activity coming up in about 3.5 minutes is opening the pre-valves between the first stage propellant tanks and the 9 Merlin 1D engines. This allows the cold liquid oxygen to flow to the top of the turbo pumps, begin chilling them in prior to ignition at T-minus 3 seconds. Now, on top of the Falcon 9, the Iridium and GRACE satellite teams, they're both reporting no issues. They have transferred internal power and checked that square at T-minus 15 minutes. The range, Vandenberg Air Force Base, the Western Range, they report they are good and ready to support launch. They're also providing weather support, and as you can see, the fog has lifted. We've got a great view of Falcon 9 with blue skies and currently a 0% probability of violating weather conditions. So at T-minus 9 minutes, 40 seconds and counting, all systems are go. In order to correctly position the satellites, the SpaceX team has to launch right on time. Today's launch window is only 1 second long. So if we delay for any reason, that dreaded hold in the countdown, we do have a backup opportunity tomorrow if conditions permit. Now we'll have a camera view on the second stage. The camera will show the 5 Iridium satellites that are on the bottom of their cylindrical dispenser. That's the area closest to the second stage. On top of that are the 2 Grace satellites that are mounted side by side on their custom dispenser. They're harder to see. In fact, the camera can't see past the 5 Iridium Next satellites, so we won't see them until hopefully after separation on orbit. Now, the 2 Grace satellites will be simultaneously deployed shortly after we get into orbit. That's about 11.5 minutes after liftoff. We're then going to have a long coast phase, as traditional for Iridium, followed by relighting the second stage engine to change the orbit to that required by the Iridium customer. Now, once we get into this new orbit, the 5 Iridium Next satellites will be deployed. That starts about 66 minutes after liftoff. We're going to release the satellites one at a time every 100 seconds. Now, as many of you remember, we've been launching Iridium satellites since the beginning of 2017. We're going to have 2 more launches after today's to finish the Iridium constellation. Now, when completed, that network will have a total of 66 active satellites as well as 9 in-orbit spares. Now, you may wonder, with this large constellation of cross-link satellites going around in low Earth orbit, what does that allow people to do? Well, one of the key capabilities of the Iridium Next system is supporting emergency situations. So let's take a look at how Iridium Next provides connectivity for emergency services and first responders around the world.
We take our safety for granted. We expect that we can make a call, be located, and be in touch when needed.
And we don't think much about our safety beyond that, until we need help.
Then we reach for our phone, we call the police, the fire department, whoever it is, we call the number. We expect to make that connection. We have faith that that call will always go through.
What if it doesn't?
What if the water is rising, the fire is getting closer, or there is a medical emergency in a remote area? You don't want to be faced with this. What if a natural disaster has destroyed phone lines and cell towers? What then? First responders need reliable, quick access to be able to coordinate relief efforts across teams in desperate situations. In today's world, staying connected is critical. How do aircraft stay connected so they get to their final destination safely? A ship in the middle of the ocean needs to stay connected, as the weather can change in a moment's notice, and emergencies can mean life or death. Threats to our safety are unpredictable. A reliable connection shouldn't be. Iridium's constellation of 66 satellites constantly orbiting the Earth means no matter where we are, anywhere, for any reason, we can have a lifeline to safety. It makes sense the new broadband service is called Iridium Certus. The name means certain and reliable. Iridium's global connectivity provides people in the air, at sea, or remote location, as well as the people committed to keeping us safe, with the peace of mind of being connected. When it comes to our safety, connectivity should never be in doubt, not have limits, and never be compromised. That's why Iridium makes the world a safer place.
That gave you a better sense of the connectivity the Iridium Next constellation will provide. As I mentioned, we also have 2 additional satellites on board mounted above the Iridium Next satellites. These are the Grace follow-on satellites. They're called follow-on because they replace 2 satellites also called Grace that were launched back in 2002. Now, the 2 Grace satellites fly in orbit about 220 kilometers apart. The satellites use microwave radio frequency signals to measure the distance between them. The measurement is accurate to about the thickness of a blood cell. It's incredibly accurate. Now, before I talked about their name, it's the mission of gravity recovery and climate experiment. The Earth's gravity will tug on each satellite at different times as they fly over mountains and seas. The accurate measurement and location that we have of the satellites allows the Earth's gravity to be measured and mapped. And knowing what causes the gravity to change slightly going around the Earth is used to understand how water is moving around the world, influencing the climate. Now we've just passed inside of T-minus 4 minutes. The transporter erector strung back is moving away from the Falcon 9. We're also finishing up loading liquid oxygen on the second and first stage. First stage should finish about 3 minutes, second stage shortly after that. Stage T TVC motion nominal just called out. That's the final check of the thrust vector control actuators that move the second stage engine in flight. Now, as we get inside of 90 seconds, you may see a large white cloud come off of that transporter erector. We're venting down gaseous oxygen from the plumbing that's in the erector, so that cloud, if we do see one, that's normal. Iridium and Grace satellites are ready to go. The teams are waiting for launch. The range is ready to support, and the weather has cooperated. As a reminder, we do have a backup launch window tomorrow if anyone calls hold. That'll be about 5 minutes earlier than today. But right now, we've just passed inside of T-minus 3 minutes and counting. Everything looking good for the flight of Falcon 9.
And stage 1 locks close up.
Strawberry Glory has closed out.
Rock, RC, countdown 1.
Rock.
Verify range is green and go for launch.
Range is green.
Stage 2 locks mode close out. Vehicle gas closeout started.
Ground gas closeout started.
AFTS is ready for launch. F9 is in startup.
LD, go for launch. T-minus 30.
Flight tanks configured for flight.
15. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Switching downrange. Stage 1 props nominal.
GC copies, we'll go.
T plus 47 seconds into flight. Falcon 9 performing nominally. We're currently throttling down the 9 Merlin 1D engines on the first stage, preparing for the period of maximum dynamic pressure and going supersonic.
Falcon 9 is supersonic.
You heard the call out, Falcon 9 is supersonic. We're throttling the Merlin 1D engines back up as we pass through the period of maximum dynamic pressure.
Maximum dynamic pressure.
A minute and a half into flight, trajectory looks good for Falcon 9. We're seeing the view from a ground camera, and obviously we're having trouble with the autofocus, but Falcon 9 continues to track downrange well. Power on the Merlin 1D engines looks good. Avionics power looks good.
MVAC engine chill has begun.
The MVAC engine chill call out indicates that we have opened the pre-valve. We're beginning to chill in the upper stage engine in preparation for ignition. Now the sequence of events coming up at T plus 245, we will have main engine cutoff. We'll shut down the 9 Merlin engines. The first stage will then separate, and we will light the second stage engine. So those activities coming up in just under 20 seconds from now. Throttling down the engines in preparation for MECO.
MECO. MVAC ignition.
Stage 1 AFTS.
We've had successful shutdown and separation. Second stage engine has lit. Major activity coming up in about 14 seconds is separation of the payload fairing. We have fairing separation confirmed. You can see 3 of the Iridium next satellites of the set of 5. As I mentioned, the Grace satellite's mounted on top of that, but not visible from the camera.
Following a nominal trajectory.
3.5 minutes into flight, we've heard the call out. The trajectory is nominal. The power on the upper stage engine is good. T plus 4 minutes since that great liftoff from Vandenberg. A view from the second stage aft-facing camera. The California coastline, we're headed south towards Antarctica. Now, as a reminder, the first stage is not going to be recovered, so there won't be any views from the drone ship downrange on this mission. We're 5 minutes into flight. Second stage engine power on the MVAC-D engine continues to look good. We're running at over 200,000 pounds of thrust in the vacuum of space. Trajectory continues to look good. Power on the second stage from the batteries mounted on the avionics rack continue to perform well. All systems continue to look good on the Falcon 9, carrying 5 Iridium next satellites and the 2 Grace follow-on satellites. T plus 6 minutes and 4 seconds into flight. Second stage of the Falcon 9 continues to perform nominally. All systems go on Falcon 9 carrying Iridium Next and Grace follow-on. Listening to call-outs from the propulsion team, everything continues to look good for the upper stage engine. Now, as a reminder, it's 6 minutes and 45 seconds into flight. This is the first burn. That'll put us into an initial orbit, following which we will deploy the Grace satellites. We'll then have a second burn that moves us into final orbit for the deployment of the Iridium Next satellites. So stay with us after we get shut down of the engine. 7 minutes into flight. As I mentioned, we'll have 2 burns. In between will be a 42-minute coast phase between the end of burn 1 and the start of burn 2. Coming up on 8 minutes into flight since launch of Falcon 9 from Space Launch Complex 4 at Vandenberg Air Force Base. We're heading south over the Pacific Ocean, headed towards Antarctica on our first of 2 burns of the upper stage engine. Now, in order to fly an efficient trajectory for both of the payloads, we're actually now running the second stage engine at lower power. That means the burn will be longer. For folks who are used to seeing us shut down the upper stage engine 9 to 9.5 minutes into flight, today we'll actually be shutting down the engine just past T plus 10 minutes into flight. That's planned for today. The longer burn at lower power obviously takes more time, but gives us a more efficient trajectory.
Stage 2 AFTSS saved.
We're just past 9 minutes into flight. Everything continues to go well. As I said before, we're headed for Antarctica right now. We will have a coast phase once we get shut down. It'll cross over the southern polar regions and then en route east of Africa, where we will relight the engine. You might have heard a call out behind me. I think some of the employees got a glimpse of one of the other cameras, and that's nominal on the second stage, so no need to worry about the expressions that you might have heard in the background.
Vehicles and terminal guidance.
We're coming up less than 30 seconds to shutdown of the second stage engine.
Cook LOS expected.
TICO.
We've had shutdown of the second stage engine. We're going to wait for call out on the orbit.
Nominal parking orbit insertion.
And what we like to hear on the speakers in the background, nominal parking orbit insertion. The first burn of the second stage is complete, but stay with us because in less than a minute, we're going to be coming up on separation and deployment of the 2 Grace follow-on satellites. While we can't see the satellites directly from the camera, we're hoping with the wider field of view of the camera that we might catch a glimpse of one or two of them passing through the field of view as they separate away from the dispenser mounted on top of the 5 Iridium Next satellites.
Grace payload deploy confirmed.
We have confirmation of deployment of the Grace follow-on satellites. So we're through the first major milestone today. The first satellites have been deployed. We're now going into a coast phase with the second stage with the 5 Iridium Next satellites still attached. We're going to resume coverage of live commentary at T plus 56 minutes, just under 44 minutes from now. We'll leave you with animations and possibly live views from space as we have ground station contact. So currently, everything looking good on Falcon 9, and we'll be back coming up for the relight of the second stage engine and the deploy of the Iridium Next satellites.
Standard Mergel as expected.
Waiting for guidance to confirm the orbit.
Good orbit insertion for Iridium payload deploys.
All right, that's what we wanted to hear. The guidance, navigation, and control engineer reports this is a good orbit for separation of the Iridium satellites. Now we're going to go through a phase of about 8 minutes. Another coast as the second stage prepares to deploy the satellites. We'll see the first of the 5 Iridium satellite deployments coming up, and what we'll do right now is pause commentary. We'll resume it at T+65 minutes, but we'll keep sending you the views of the Falcon 9 second stage with the 5 Iridium Next satellites as we get ready for separation of those satellites coming up in just about 8 minutes from now. Welcome back. John Isparker with the webcast commentary here from SpaceX headquarters in Hawthorne, California. We're just past 65 minutes since a great launch of Falcon 9. We're setting up for the first of 5 deployments of Iridium Next satellites. The first satellite planned to deploy in about 25 seconds from now. Currently, you can see the camera on stage 2 looking at the upper stage engine. That white object you see is solid oxygen, very fluffy, lighter than a snowball. And that is normal at this stage of the flight.
First Iridium satellite payload deploy confirmed.
And a nice visual confirmation of the first of the 5 Iridium Next satellites being deployed off of the dispenser mounted on top of the second stage of Falcon 9. As I mentioned, we're going to do 5 deployments, 100 seconds between each deployment. So at the first one behind us, we're now 70 seconds away from the next deployment. Coming up on the second deployment in about 5 seconds from now.
Second Iridium satellite payload deploy confirmed.
Another nice view of the second Iridium satellite being deployed. That leaves 3 to go. I believe the next one is on the far side of the dispenser, so we'll only have verbal confirmation of that. I don't think we're going to see it in the camera. That'll be coming up in about 75 seconds from now. Also, as a note, while we're in the coast phase over Antarctica, the customer has confirmed their ground station in Antarctica has made contact with the Grace follow-on satellites. So that indicates we had good separation of those satellites, and they are now talking to their ground station. In about 5 seconds, deployment of the third of the 5 Iridium Next satellites.
Third Iridium satellite payload deploy confirmed.
Confirmation, satellite number 3 has separated. Didn't get a view of this one from the camera up on top of the second stage, but I believe the 4th one coming up, that'll be the close-up of the one that's right in the center of the field of view. Waiting for the second stage camera to switch back to a view of the Iridium satellites. There it is, coming up in 5 seconds for deployment of number 4.
Fifth Iridium satellite payload deploy confirmed.
A nice view of Iridium deployment off of the dispenser. That'll leave us with 1 more to go out of the 5 Iridium Next satellites carried on this mission. That'll come up in 78 seconds from now. Last deployment coming up in 5 seconds.
Fifth Iridium satellite payload deploy confirmed.
Confirmation of the 5th of all 5 Iridium Next satellites successfully deployed. And that's a clean sweep again for deployments today. And that's going to bring an end to our webcast. It's been a great Falcon 9 day here in Hawthorne and at Vandenberg Air Force Base. We had an on-time launch of Falcon 9. First stage had a great flight. We saw stage separation live on the cameras. Shortly after that, payload fairing separation. And we're following payload fairings. Both successfully deployed parachutes, but they landed in the Pacific Ocean. The fairing recovery ship, Mr. Steven, came very close, but not quite. We're going to keep working on that. But meanwhile, second stage went into a great orbit. We heard the 2 Grace follow-on satellites separate. They've already been in contact with their ground station. We then saw the relight, and just now, all 5 Iridium satellites separating every 100 seconds, just as clockwork. We'd like to thank our Iridium customer and our NASA customer, as well as the United States Air Force for range support, and our licensing agency, the Federal Aviation Administration. Please follow us on social media, on Twitter and on Instagram. Look for launch photos on our Flickr webpage, and of course, at SpaceX.com. Thanks for letting us share the mission of Falcon 9 with you, and join us on our next upcoming flight out of Cape Canaveral at the end of May. With that, have a great day.